Hello, everyone. Nice to see you all again. So this class, we're going to continue our discussion about the computational methods in engineering, and specifically, we're going to introduce MATLAB. Okay. So if you recall our last class, or do a recap of our last class, we introduced the course layout. We said that we're going to quickly go over the Excel, did some practice problems of the Excel in our last class. And basically, in our last class, we covered these three aspects. So we introduced the basic operations and functions in Excel, how to manage a small data set, relatively small data set. We also try to look at how we can solve problems and using the how to use a goal seek, right? So a lot of times, if the equations for solving the problems are linear, or you can have a basically the solution directly coming from the derivation of the equation, right? You can directly solve it by setting up the equation in Excel. But when you encounter nonlinear systems, so basically you cannot obtain the expression or the function of the goal or of your solution, then we will use the goal seek. Basically, it's an iterative process that the Excel uses to find the actual solution. And then the third is data visualization, how to make simple plots, right? So we created some scatter plots and how to do interpolation, right? We can interpolate with linear, exponential, polynomial, and so on, and how to include the error bars in our plots. So this class, we're going to start with the MATLAB, right? So basically here is an overall objective of learning the MATLAB in this course. So we're going to achieve the following 5 objectives. First is to learn how to evaluate and explore capability of the MATLAB. Second is to learn how to do technical computing with MATLAB. Third is learn how to design mathematical procedures and solve technical problems via a structured plan, right? So to design the methodology or solving technical problems. So specifically, we're going to talk about the MATLAB structure later on in our class so that we can do iterative process to either find the goal or find the final solution for our equations, for our engineering problems. And then we want to learn how to develop algorithms to implement the steps of your structured plan. And then finally, learn how to translate structured plans into computer programs and to solve engineering scientific problems. Specifically for this class, right, the first class of the MATLAB courses, right, the first class of the following, I would say, at least 10 classes regarding MATLAB. So here we just want to provide an overview of some of the features for MATLAB so that you can begin your experiment, right? You can begin your practice by evaluating this new technical computing tool, right? We introduced Excel in our last class, right? So you can see that Excel can come quite in handy, right? Especially if you're dealing with smaller data sets. And MATLAB is very good with dealing larger data sets and also sophisticated calculations in the in analyzing data. For example, last class we talked about the goal seek, right? So you see in Excel, the goal seek can only be done at a point-by-point calculation, right? It cannot, for example, do the goal seek for 10 equations, right? But in MATLAB, you can do that. Right? You can do that in an iterative process or directly using one function to do the goal seek, right? Solve multiple solutions. So we can also begin the training in the art of computer programming, how to write elegant programs, right? And also informative programs, basically to comment on your programs so that yourself and your colleagues, your friends, classmates can understand your coding. And also we need to, we're going to learn in this class how to use MATLAB as a notepad for mathematical computations that you encounter in engineering science courses. Okay, so first, let's talk about the MATLAB user interface. So as you can see on the right-hand side, right? So I'm already opening a MATLAB interface, right? So this is currently using the Microsoft Windows interface, right? As you can see from these buttons on the right. So basically, you can divide your user interface for MATLAB into several blocks, right? So the one in the middle is the one that has these shining cursor here is called the command window. So inside the command window, you can type in any function you want, right? So for example, it's similar to what you have in Excel. So in Excel, you have PV equals nRT and you plug in values, right? So here it's the same if you know the values of the exact parameters. For example, if you want to calculate 1 plus 1, right, you just type in 1 plus 1, right? So if I multiply by 10, we get 50, right? The answer is 50 here. So basically this is command window where you can type in simple commands or relatively a few lines of the commands that you want the MATLAB to solve. And then, so before introducing the different blocks, I know that some of you also use the Mac, right? So Mac also has MATLAB. And if you look at the user interface, it's actually quite similar. Okay, except here the close, these buttons are now over on the left-hand side, right? But overall, they look quite similar. Okay. So if you divide these this user interface to different blocks, you have the command window, you have the workspace window, right? So if you see over here, you have the workspace. So basically inside the workspace, you have all the values or the variables that you define in the command window, okay? And there's also a current directory window, which is on the left-hand side. So normally, you can set up your current directory or current folder so that, for example, you can put all your scripts or put all your files or even textbooks, right? E-books in this folder to specify, hey, this is the folder for my project or for my class. So it's easier to keep all the materials or keep all the documents in the same folder so you don't lose track of them. And later, we're also going to show how the current directories play a role when you are working with a group of scripts or group of functions, right? So basically, the MATLAB will only recognize the files in your specified directories or specified folders. Okay, so for example, right now, if I want to call some functions in this current folder, you see these folders are grayed out, right? So basically, MATLAB is not going to go inside these folders to read these functions or read these files, but the MATLAB can read all of these files over here. Okay, so if you just type in certain scripts. And then for the earlier version of the MATLAB, there's also a block called the command history window. Okay, so the command history window, some of them they're located over here. So basically, it's an easier way for you to keep track of all your previous commands. For example, if you want to modify something, right? So I think over here, what we can do is we can go to the layout and then command history. You can do docked, right? So basically, it's going to show up here. We can see our commands over here. You can copy some of the commands, right? Control C and then Control V over here again, right? So basically, it's an easier way to keep track of all your previous commands, and you can copy and paste all the commands you have typed in. So for example, before the class, I was searching for how to create a soundtrack using the MATLAB, right? So I just searched online and find some scripts you can type in here. I don't know if this is going to get recorded, but you can actually hear this short music of that's created by MATLAB. Although it doesn't sound very fabulous here, but you can create different pitches, different notes with frequencies, and you can just do that with a few lines. Okay, although it looks quite cumbersome right now compared to just if you use your finger to type in, right, or use MATLAB to type in. But you can see that MATLAB can do quite a lot of work. But the thing is that here you can easily change the duration of the notes, right? You can also change the sound of the note, right? You can change the overall let's say you can easily change certain notes by changing some of the I would say the pitch over here, right? So for example, if you change this to C, right? So let's copy over here. If you change this one to C, okay. do this one. You see, so basically here the node name are the ones that you're going to you pre-specified, and then this is the twinkle twinkle that we have, right? So you can easily change certain nodes and then make a difference. So you can also change the duration of each node, right? So for example, you can change that to 0.6. Right? So these are easy to operate in the command window, and then you can easily retrieve them from the command history to see what you have done before. Okay, so this is the command history, and you can access it from your previous command, but you can actually also just search for it by using the up arrow or down arrow. Okay, so basically, if you want to get everything from your previous code, then you can just click Shift plus up, and then it's going to copy everything here. Or if you want to just get the previous node or the previous code that you type in, you just click up arrow once, and then you can get the previous node. Okay. So this is the MATLAB user interface. And then again, to quickly go over these different blocks, you have the command window. So the command window is on the main panel where you interact with the MATLAB. So on the right, basically it's in the middle right now. It depends on how you arrange all of your panels in MATLAB. So you type and enter the command after this prompt, right? So after these greater signs here, double greater signs, and then MATLAB executes the command and display the results if you request it. Right? So for example, if you want to get 1 + 1, then you get 2. But at the same time, if you don't want to request it, then you put a semicolon, right? And then it's not going to give you anything, although it actually already did the calculation. Okay, so some commonly used tools and commands. Up arrow returns the last command input, can be repeated. We have done it already. CLC is clear the screen, because right now you can see that our screen can get quite messy from the command window, right? So you just type in CLC, and then the commands, at least the command window here, is cleared out. But you can see that in the command history, all of these commands are still there, right? So you can type in whos, right? So this is going to give you a list of variables that we already have in the system. For example, in the previous set of code that I created to sing the Twinkle Twinkle, I defined a few variables, right? Short, the node name, the node create, or song, right? These are variables. Okay, some of them have specific values, some of them have different format. We're going to talk about that later on, but you can see that we define these variables, right? So if you want to clear all of these variables, what you do is you just type in clear, and then it's going to sort of clear the memory of these variables that you just created, right? But now if you want to just regenerate these variables again, you can copy these commands, paste it here, type in again, and you see the variables just come back, because the MATLAB executed these codes here, so that you basically MATLAB will memorize these variables and store them over here. Okay, so now let's just clear the screen and then clear all of the variables again. Okay, so well, we can do some simple examples, right? We can just use MATLAB as a calculator, right? So you can do 2 + 3, make it a little bit more complicated, right? We have been typing 1 + 1, 2 + 3 is 5, right? So you can do CLC, whos. You type in whos, then it's the answer, right? It's the answer that we just got by 2 + 3, which is 5. Okay. So the next one is the command history window. I think I already talked about that. Command history window logs all of the commands you entered in MATLAB. This is the one that you entered through the command window. Okay, so basically it should, if you check what we just did, you should have logged 2 + 3, CLC, and who, right? So then you can also copy it and paste your previous command, or you can just do the shift to press shift and basically click the range of the codes you want to copy and paste again, and then you get all the codes, right? So now again, some practice here, right? 3 plus, we just did 2 plus 3, we can do 3 minus 2, right? 3 multiplied by 2, just use it as a calculator. So it's computer program, so you would expect it to be accurate. So 3 to the power of 2, 9. What about 2 divided by 0? It's going to give you infinity, right? So infinity is not a number here, but it basically MATLAB will recognize as a value, which is called infinity. Okay, so and then you could also do, for example, let's see, 0 divided by 0, right? 0 divided by 0 is not infinity. So you see this value of NaN, it's not a number, it stands for not a number. So similar to infinity, so MATLAB are going to record these values, right? So basically they are still considered as a value, right? But it's just they don't have a real number that you can do the calculation, okay? So this is not a number. So basically, even if you just define, for example, you have a value number that you can define it to be, you can define A to be equal to 2, basically give the A or letter A or variable A with the value of 2, you can do this command. And you can also give A the value of not a number, or give the A the value of infinity. But you cannot give A the value of like any letter here, right? Because this is not a function or variable or value that can be given to A. So what I'm trying to say is that MATLAB treats not a number and infinity similar to values, right? So it's not a random string that we can give directly to any variable. Right? So we can also try 3 multiplied by infinity. Right? So the answer is still infinity. 3 multiplied by not a number. Right? It's also not a number. Okay. So now, as we said, we were just trying to use everything as a calculator, right? So now we can start to include functions, right? We can start to give certain variables, certain values, right? For example, we can give A the value of 3, right? A equals 3 means that now A has a value of 3. And at the same time, you can see on the right-hand side, in the workspace, we start to have the variable value of variable of A with a value of 3. So we can also do B equals 2, right? So we have B having the value of 2. And now we can start to do calculation with just these variables. We can do A minus B and see what we get. That's 1. A divided by B, 1.5, right? So one thing you can notice here is that it's 1.5000. Okay, so your question might be, well, why does it only, why doesn't just show 1.5? Why does it show these so many zeros behind it? So this is related to the rounding error of these computational tools. So if you give it the full digits, full number of digits of this value, you will see that for the calculations in these computational tools, they will go all the way, let's say, to 15 or 16 digits of 0 until it hits a 1 at the end, right? This is related to the rounding error or inherent error that's associated with these computational tools. So similar thing, for example, if you want to calculate the sine value of pi, right? We know that sine of 2 pi, pi over 2, that's 1. But if you do sine of pi, you see, theoretically, you should be getting 0, but you're getting a very, very small value here. This is a rounding error that's associated with the computational tool here. Okay, so basically, it's not 0, but it's almost 0, right? So we just did A divided by B. We can also do A to the power of 2, right? That's 9. We can give the C value to be A multiplied by B, that's 6, or give the D value of C to the power of B plus 1, right? So B plus 1 is what, 3. So c to the power of 3, that's gonna be like 216. So that's 36 multiplied by 6 is 216. So it's correct. So now if you want to see all the variables, right, you have A, B, C, D, and answer. So we get this answer variable when we don't have any, when we don't give the variable, or we don't give these calculations to any variable. For example, if you just do A multiplied by B and without assigning this value to any variable, you will just get answer equal to, right? So answer here is a variable, okay? So this is command history window. There's also the workspace window. As a workspace window, we already introduced it. You have all of these variables that are recorded. These are sort of like the memory that the MATLAB has from doing the calculation in the command window, okay? So I think we sort of already did this, right? D equals this, we typed in who, and then well, we already have the A, B, C, and D. So now if, so one interesting thing or one helpful thing for MATLAB is that basically you can make comments to your code. So you can type in something that the MATLAB doesn't record at all, right? So this is only for your personal reference. For example, I want to see that, oh, A, B, C, and D are important values for tomorrow. You have to memorize it. You have to know it. But at the same time, MATLAB doesn't have to know this information. It's only for your personal reference. So you can type in this percent sign here, right? You can see that the code start to change to green. And then you can type in whatever, right? So I need to memorize A, B, C, D for my next class, right? If I type in, nothing happens, okay? So this is only for your personal reference, right? So you type in that, so next time when you copy, right? For example, if you do the calculation again, right? Next time when you copy everything from the command window, right? I basically says, oh, I need to memorize these for my next class, right? But MATLAB doesn't basically run this code by itself, doesn't run the code, okay? So now if you type in A, B, C, D, then you have the values of A, B, C, and D because they're in memory. But if they're gone, for example, if you do clear the memory and type in A, B, C, D again, there's nothing because the MATLAB doesn't have these variables in the memory or in the workspace anymore. Okay, so now we can actually also use MATLAB to do some simple plots. Okay, so for example, these are just some simple scripts. We're going to have a 1 or 2 classes just talking about plotting with MATLAB. But here, I'm just going to give you a very simple example, right? So let's do clear CLC, clean our screen also. You don't have to do this. This is just for personal convenience, right? Sometimes people may find it bothering to work on a command window that has a lot of codes. But for me, I don't always clear my screen. Okay, so first we're trying to create a plot that shows the function of y equals x to the power of 2. So we know that y equals x to the power 2 is a parabolic function, right? So it has the U shape. So how do we make that? So we first need to define the variable, right? So the variable, we know that on the x-axis is the x, right? So we need to define an array of x values. So the way we define it is 0 column, right? 0.1 column 1. So what does this mean is that we're trying to define an array giving the x and the value of an array. So the array starts from the value 0 to the value of 1, and it has an interval of 0.1. Okay, so now if you see the x value, it has 11 columns, right? It has value 0, 0.1, 0.2, 0.3, all the way to 1. Okay, so now we need to define y. So y is equal to x to the power of 2. But one thing we need to pay attention to here is that in MATLAB, right? So when we want to do the x to the power of 2, I mean, this is related to your linear algebra that you took in your first year, right? So when we do the array calculations, there is this point multiply or directly multiply. If you directly multiply, right, so you're trying to calculate using matrix. And if you want to do the matrix calculation, the row number and the column number has to match, right? So here we're trying to do x multiplied by x, and you have basically two rows of matrix, and they cannot do the multiplication. Okay, so instead we should be doing the dot multiply. Okay, so we're going to talk about these in the future too. So possibly in our next class. So what it does is that the x square only does the square calculation within the value, within each cell by itself. It doesn't interfere with other cells. Okay, so just do the square calculation here, calculation by itself, right? So then, and then you get this value. Okay, so y equals this variable or this array. It has 11 columns, right? And it has a value of like specific values, which are the square of the x value in each cell. Okay, so now if you type in whos, these are the variables, right? You can see x and y. This one has, or this matrix has the size of one row and 11 columns. The same thing for the y, 1 row and 11 columns. So now how to plot it out? So we can just do simple ones, x, y. Okay, so now a plot is going to pop out. This is how it looks like. Okay, so the x-axis is x value, the y-axis is y value. Okay, so here you can see that, well, basically it's, if you zoom in, right? So it's, if you use the concept that we had for our last class, it's a line plot, it's a scatter plot, right? And between each scattered points, right, it's a straight line. So you may want to also highlight the specific value that we had for the x and y, right? You may want to show the marker. So what you can do is plot x, y, and then x, y with marker, right? So the marker are circle markers. Okay, so now if you plot it out, it's going to have this shape, right? So we're going to talk about the plot function later on in our class. So basically you can do a lot of format changes, right? So for example, you can include the X label or the X title, right? You can just type in label X, Y label Y, and you can also change the line width, the type of the marker that you want, right? So right now we're having this circle marker. You can also use the plus marker, right? The plus sign. And then I'm just retrieving my previous commands, right? Using the command history, just typing up arrow and use shift sign. Then you can include these extra label markers, right? Or the labels for the x and y axis. We're going to talk about this plot function later on too. So you can see that MATLAB can also easily do plots. You just need to type in a few lines and that is going to make you the plot. And although right now you may think that plot doesn't look as nice as the Excel, and trust me, it can do much more plots with much better formats. You just need to wait patiently later, and we'll show you how to make these nice plots. And many people actually use MATLAB to create scientific figures that are published in Science or Nature. Okay, you can make really fancy plots with MATLAB, similar to the notes. Right? You can make a song with MATLAB too. Who could imagine that? Right? Excel cannot make songs. Okay. So now we can start to write a simple program. And for your convenience, I'll clean my screen again and maybe clear all the variables again. So consider computing the volume of a cone, right? So if you consider for the cone. Let me see if there's a way for me to draw a cone shape. Well, maybe I'll just use a triangle, right? And also include a circle. Okay, so this is cone. So basically we know that for the cone, the way we calculate its area is we use the area of the base multiplied by height and divide by 3, right? So the area of the base is pi multiplied by r squared, right? Pi r squared, that's the circle's area, right? Multiplied by height of the cone, and divide by 3. Basically, this is volume. Okay, it has a radius of 6 inches, height is 12 inches. Unfortunately, here it's not showing the standard units, but it's fine, right? We're calculating the volume just using the imperial unit sets, so it's okay. So then the way we calculate the area is we can define r equals 6, that's the radius, right? Height equals 12. And then the volume, V, should be equal to pi multiplied by r squared multiplied by h divided by 3. Okay, so one thing we should notice is that r and h here, they're not array anymore. It's not like the last problem where you have an array of x values. If it's just a single value, what we call a scalar, right? If it's single value, which is a scalar, then you don't need the dot calculation. Although if you use a dot calculation, it's still the same. Okay, so either scalar or array, or later on if you use the matrix to do the calculation, right? I would say, well, for the scalars, the calculation, if you include the dot or not include the dot, the answer is always the same. It's the volume is here. Now, if you have the whose, so you have the values, right, the list of variables. And if you see from the workspace, it also includes the values over here. Okay, so now we can just refer to this example in our textbook. So it's talking about the conversion of energy, matter to energy, right? Everyone know who this is, right? It's Albert Einstein. He has done or contributed so much to the modern physics, right? So his work can probably win many Nobel Prize, but one of the most important finding from his research or his studies is the conversion of the matter to energy, which is E equals mc squared, right? So here we're trying to apply this equation to our sun and see how much of the mass is needed to generate the energy that's produced by our sun. Okay, so here the problem states that the sun radiates 385 multiplied by 10 to the 24th joule per second of energy, all of which is generated by nuclear reaction coming from matter to energy, right? Use MATLAB and Einstein's equation to determine how much of the matter must be converted to energy to produce such amount of radiation in one day, right? So you have the energy, sort of the power from the sun, that's per second. You want to see how much of the mass is used per day. So we need to first basically convert this energy or this power to the total energy that's in a day, right? So we can define basically E equals, or let's say define P, it's a power, right? Joule per second is watt. So it's 385 multiplied by 10 to the power of 24, right? This is the power. So E should be equal to power multiplied by time, right? So this is per second. And every day you have 24 hours, and each hour is 3,600 seconds. So you're going to have P multiplied by 24 multiplied by 3,600. And you can notice here that sometimes I have a space in between, sometimes I don't. So I have to say that this is not a good programming habit. So you either everywhere have space or don't have space at all, right? So one thing I want to notice that in the equation, if you have a space here, it is okay. Okay, but when you define variables, if there's a space, then the function is not going to read it. Okay, when we talk about the definition of variables later, or the proper names of variables later on. Okay, so now you have E. So then to calculate the mass, we just need to divide E by the c squared, right? So now we need to define c, which is the speed of light. So I have the value over here, 3.0 multiplied by 10 to the 8, right? So that's C. So one thing I also want to notice is that, well, you may see, I think in Excel, we can do the same, right? So if you want to specify a value that has the basically exact value of 3 multiplied by 10 to the something, right? You could use this, or you can also just use C equals 3E8, right? 3E8 is 10 to the power of 8. Okay, you can see that these two have the same values here, right? So I personally, I like 3E8 better, right? This is more simple. It gives you the exact value of a large number. Okay, so now you have C, you have E, you can calculate mass, right? So the mass, we know that mass equals E divided by C squared. All again, C is a scalar, it's a single value. So you do not need dot over here. Although if you have the dot here, you get the same value. Okay? So that is the mass. So this is mass loss from the mass to energy conversion for the sun for every day. This is carrying a unit of kilograms because we're using standard unit everywhere. So then we may wonder, well, looks like this is a very big value, right? So almost 4 multiplied by 10 to the 14th kilogram. This is a large value. But then at the same time, I have it here, the sun has a total mass of something multiplied by 10 to the 20th. Okay, so this is basically it's a very, very large value for the total mass of the sun. So let me just quickly search the mass of the sun. Instead of 20th, it's actually 30th, right? So it's close to 2 multiplied by 10 to the 30th kilograms. So let's just define mass sun. So you see I have a lower dash sign here. This is the correct way of defining a variable. We're going to talk about the variable definition later on, not just do simply a space. You see, if you do a space here, even the color of the code changes, right? You cannot do dash directly because this is not a variable, right? You cannot do space. So you should do mass sun or mass S equals 2E30. This is the mass of the sun, total mass of the sun. This is the the mass of the sun's loss per 1 day, right? So if you calculate how long it takes for the sun to burn out, so you would do mass of sun divided by m, right? This is this many of days. Right? Let's say define day total equals this, right? So if you convert that to years, year total equals day total divided by 365, right? It takes this many years, right? So this is a way more than, so basically way more than billion of years, right? So basically we cannot see that thing. At least you guys, including me, we cannot see that thing. So that's why the sun is so precious. It provides us with constant heat and energy that basically created life on Earth. This is a simple program that we can use to do some simple calculations. And if you want to come back to this program later on, right, you can access these commands, right? You basically, even if you close the MATLAB program, unless you uninstall it, right? If you uninstall it, then it will keep all of these commands. But if you close the program and open it up again, you're going to see these commands. Okay, but just for safety issue, you may want to save your code. We're going to talk about how you can save the code, save your unfinished work later on as well. Right, so this is the answer for our problem here, right? So in this class, we're going to introduce the basics of MATLAB. So some definitions as well, right? There are variables and arrays. We sort of talked about this earlier. So like when we were defining the x values, trying to make the plots, we defined a 1×11 array, right? 1 means the row number, 11 means the column number. It's always like this. Start with the row and then the column. Okay, so 1×11 means 1 row, 11 columns. The rows come first. Right, so maybe an easier way for you to memorize this is, well, whenever we sit in a class, right? So you want to sit closer to the classroom. You want to have a smaller row number, right? So the row number is actually more important than your column number. Okay, so I mean, I'm just talking about it in the setting of the classroom, right? But actually in your coding, it doesn't matter too much, right? So then this is an easier way for you to memorize. So the first comes the row, right? The second comes the column. Okay, so what are variables? Variables are arrays of numbers, right? Even a single number, a scalar, is also an array. It's just a 1×1 array, right? 1×1 matrix. You name the variable as a programmer and assign them with numerical values, like with what we did, x equals this array, or we did c equals a multiplied by b after we define the value of a and b. You execute assignment command to place the variable in the workspace memory, right? Memory is a hard part of hardware for storing the information. If you clear the memory, then these variables are gone. And then you're allowed to use the variable you're allowed to use this variable in the algebraic equations after it's assigned, right? So after we assign a and b, we can just write out the equation to do the calculation. Okay, so now we can talk about the variable naming rules. So just as I said, you can name parameter with m lower dash of or underscore of s, right? But you cannot name a parameter with m space sun. Right? So let's see. If we just do m sun equals 1, right? You cannot use that. So because here it will recognize it actually as a minus. Okay. So, or you can also try m sun equals 1, right? So it won't recognize it, but it will recognize m underscore 1 as a permitted name for the variable. So basically, these are the rules for the variables. It must start with a letter, right? So if you do 1 ms, right, it's not allowed. Invalid expression. So it may only contain letters, numbers, and underscores, right? Letters, numbers, and underscores. But at the same time, it must start with a letter. So for example, you can do ms1. For example, the sun number 1, you're talking about another galaxy, right? Sun number 2, sun number 3. As soon as the number doesn't start, you can use that name. So no space or punctuation marks are allowed, right? So no space, punctuation, other types of marks that are allowed. Only the first 63 characters are significant. Beyond that, names are truncated. So this is related to the memory that's that's permitted for each of the variable. So you only record the first 63 characters. It's also case sensitive. So the lower a and the upper a are not the same. Okay, this is something that we need to know. For example, if you specify the uppercase a with a value of, let's say AA, with a value of 1, if you type in AA, it won't recognize it. But if you type in uppercase a, it will right? So basically the lowercase or the case matters. Lowercase or uppercase matters when you use or call these variables. So now let's see whether these names are valid, right? The variable names are valid. First one, it's not valid, right? It starts with a number. Second one, it is valid, right? It doesn't have to be a combination of name or a combination of letters and numbers, right? Just like your password, right? It can be pure, it can be pure letters, right? So tertiary sector, right? So note that if you define this variable, give it certain value, the S, the uppercase S here matters, right? If you try to call it with a lowercase of s, then it doesn't recognize this value, this variable. Blue cows, no, because there's a space in between. Apple 65 works. Red bananas, this is an underscore sign, works. What about this long one here? So we can try this. Okay. So you can see that it also has this percent sign. So let's just try to type in. They could also copy to the enter. Okay, so let's do this one. Before that, let me clean up the screen. Okay, so this is what we have. So you can see the the percent sign is a comment, right? Saying that red part is not part of the recognized name, but let's try. Okay. Well, let's assign this variable with the value of 1. Okay, first they give you the warning. This variable name is quite possibly too long. MATLAB maximum name length of 63 characters will be truncated to this variable name. It's quite possibly too long to be considered. And finish at here, right? At this underscore. And then if you open up this variable, double click, right? So you can see that the variable name is just over here and it has a value of 1, right? As I mentioned, even a single value, right, is considered as a matrix. So it's a 1-by-1 matrix. That's why MATLAB has this name of MAT right here. MAT means matrix, okay? So all of the calculations are done in the matrix or array. So similarly, here are some tests, the exercise from your textbook, right? So these are okay if it's not, because this is not permitted. So later on, basically this is being used in the structures. So you can try to type in, or we can try to type in here. You can see if you type in if, it's automatically recognizing it as a structure. Okay, so it's being used in a structure. If you type in if equals 1, then it's not going to be assigned. Okay, so my book, dash sign not allowed, question mark not allowed, first number not allowed. All right, so you can just try and see whether that's allowed. Then you'll get a better sense, right? So only letters, numbers, and underscore. Okay, and also in terms of the letters, the case matters. Okay, so naming conventions. This is talking about a good habit of working on your code, right? So there are different ways to name variables. The following illustrates some of the conventions, right? So the habits that people use. So you can use the lowercase, right? But only use the lowercase for the first word. For example, we're talking about, let's say, I'm trying to log the student's final score, right? We're talking about a large data set. So we can do student, let's say myself, right? Young Wang, okay? It has a value of, let's do full score, okay? And then student, Ruoyu Zhang, who is your TA, right, has even better score, let's say 200, okay? And you can also use a convention of uppercase, okay? This is just personal habits, but what I'm trying to say is that once you select a format or a convention, just try to stick to it, right? So it's talking about good habit of coding so that it's convenient for you, yourself, and also for your colleagues or your classmates to understand your code. Right? So if a variable is a constant, some programmers will use all caps, right? So constant, for example, the Boltzmann constants, right? Constant, right? You can just type it like that, and then equals, or I think some people just use KB, right? K is the constant, right? K, and then B stands for Boltzmann. So I think that's 1.38. Check. Boltzmann constant 1.38 multiplied by 2 to the minus E minus 23. Okay, 10 to the minus 23. Okay, so here I also mentioned that it doesn't matter which convention you want to work with, as long as you know what it means, right? You can just use A or B. A lot of times A and B, you might get it confused, and then it will all end up in the workspace and might override some of the values. Right? So it's better to have your own name convention, and then you know what your code clearly writes about. So now here we will talk about the way that MATLAB recognize different variables. Okay, it actually recognize variables, all of them as arrays or as matrix. Okay, a variable is stored as an array of numbers when a property is interpreted as a scalar, vector, or matrix. Okay, scalar is one by one, right? It's a one by one vector. Vector, it can be n by one or one by n. We're talking about n by one, that's many, many rows, right? One by n, that's many, many columns. So we said the first one stands for row, the second one stands for column. Okay, either easier way to memorize it. First one, row in a classroom, your row number is more important than your column number, right? Because you want to stay close to the classroom, stay close to the teacher, right? Stay close to the blackboard. So the same thing for matrix. If you have an n by m matrix, it means that there are n rows and m columns. The size of an array is specified by the number of rows and number of columns in the array, with numbers of rows indicated first, right? So scalars are one by one arrays, and they contain a single value. For example, we calculate the the volume of the cone, right? So an easier way to recall the code that we input over here is, instead of using up arrow, you can also do R equals and then type in up, right? So it's going to automatically go to the memory, right? Go to the command, or for example, if you want to find out the find out the equation that we define V, then you can just do R V equals and then use up arrow, and then you're going to see this equation that we typed in before, right? This is an easier way to find the code that you just typed in, right? So basically these values are stored in scalars. That's one by one matrix or one by one array, okay? A vector is a list of numbers expressed as one-dimensional array. A vector can be one by one or one by n, right? The columns are separated by commas, right? So for example, if we just try to create the height or h with 3 columns, okay, so you can see that h is here. And if you try to open up h from the workspace, you can see it has 3 columns. Right? They're separated by commas. You can also use space. Actually, space is the same as comma here when you define the when it's related to the columns, right? So, for example, you can also do I equals 1, 2, 3, right? 1 equals 1, comma 2, comma 3, right? This is quite similar to what we had before when we were trying to define x equals this, right? So instead, the difference is here we're using space or comma, but here we're using column, right? So when you change that to column, you're basically creating an array that starts from 0, end at 1, and the interval is 0.1. So the same thing, you can try, for example, create an array that's start from 1 to let's say 100, right? It's separated by 1. It's going to be a long array. It has 100 columns. So if you open up the X, right? So this is how the X looks like over here. So yeah, we just define it over here, right? So J is 1 to 100, and then it's separated by what? By 1, okay? And then rows are separated by semicolons. Right? Semicolons, basically, it's sort of like the end of each code, right? So we said that basically it's going to a new row. It's new row. So if you type in H equals these, so you're going to have H 12, 13, 14. And so if you go to the H again, in the workspace, now you have 3 rows. And then same thing, you can do I equals 1, 2, 3, and then you can get 3 rows. Okay. Matrix. So matrix is a 2-dimensional array of numbers, right? So we call it as an array, but actually this is more like a matrix. Right? So MATLAB, MAT stands for matrix. So basically it starts, as we mentioned again, it starts from the row number to the column number, right? For example, this is a matrix, right? It has 4 rows, 3 columns. To define this matrix, then we can just do M. It can be any name. You can define it as X. And then, as we said before, so it starts from, for each row, they're separated by space or column, space or comma, right? So if you want to define it, it's 3, 1.8, 3.6. And then semicolon to the next row, 4.6 minus 2, 21.3. Another semicolon, 0 minus 6.1, 12.8. Another semicolon, 2.3, 0.3, minus 6.1. Okay, so now you have this matrix. So if you double click on the X, you can see that this is a matrix. It has 4 rows, 3 columns. Okay, so now how do we find each value in the matrix? Okay, so one thing we didn't mention is how do we find, let's say we were defining X, right? We were defining this H. H is this, right? We can actually make H a little bit longer. Let's do 12, separate by 1, go to 30. Okay, this is H. So how do we obtain the, let's say, the 5th number in this array? Okay, so how do we find it? Let's say right now you can directly see it's 16. Say we just make it even bigger, 3,000. So how do we access the, let's say, the 200s of the 200s number in this array? So what you do is you just put in 200 and you get the value 221. So if you're interested, you can go up to column 200. Okay, 200, 221. Right, it's 221. So you just need, for an array, you just need to type in the index that you want to look at, and then it's going to give you the value. Okay, so what about matrix? Now you have this X here. So how do you, for example, access the 3rd row, 2nd column? Right, so the way you do that is you X 3, 2. Remember, row come first, right? Rows come first and column comes second. So now if you see the 3rd row, 2nd column, minus 6.1. Okay, so here it's trying to access it, right? So let's do M23, which is 2nd row, 3rd column. Oh, no, not X, right? We're defining as, not M, we're defining as X. So then you have this one, right? 21.3. Okay. So hands-on exercise, enter the following into MATLAB, right? Scalar, you can define it as 1, vector B equals 1, right? Again, in terms of bracket, right? Use the square bracket. Okay, 1, 0, 2, right? There's a row, and then another row. Okay, but if you change it to semicolon, the columns. So then what if, let's say, you create a row and then do it like this? What's going to happen? It's going to say that the dimensions are not consistent. Okay, so I mean, don't be afraid to make mistakes, because some obvious mistakes MATLAB is going to point it out. Right? If not, we have to debug it, and I'll show you how to debug your code later. Okay, so now you can also define a matrix. To save some time, I'll just copy everything over here. Right, you can see that now we created this matrix. Okay, so yeah, this is how you define it. Let's say if you want to access the second row, second column, then you just do D22. So you may say that, well, this is very obvious. We can just do that with a piece of paper, right? The thing is, a lot of times when you are dealing with large data sets, it's very difficult to see the value directly from the spreadsheet. Okay, so later on, I'm going to share with you some data sets or big data sets, but it's occasionally you will have to access certain value from this big table. If you just drag it, you're never going to get it, right? So this is where the MATLAB is very powerful about. It's very easy to manage large data sets. Okay. So the next is the operations, scalar and array operations. So basically operations are basically doing these plus, minus, multiply, and taking a ratio or division, right? So if it's scalar, right, it's like A and B here, right? A, B, or not B is a array now. So let's say we define B as a number again, A equals 1. So by the way, if you have a value that's already defined and then give it a new value, you're just going to override. Okay, so this is also why you want to be creative when you define your variable names, because you don't want to have, let's say, define ABC all the time and then until they override each other and you lose track of what variable you're using. Okay, you want to be creative and also consistent, having a good habit in defining different variables, but not too long. We said the longest is 63 letters, right? 63, I would say, spaces. So now if you want to do the calculation, if they're scalar, then you can just do A plus B, A minus B, A multiplied by B, A divided by B. If it's involving exponential calculation, right, exponentiation, right, you will do the upper tick, right? So A to the power of B, you will do this. Okay, this is scalar. Scalar is very easy, right? What about arrays? So we already mentioned earlier that when we're trying to do x, right, so now x equals, let's try this one. So this is too long. We want a shorter one, right? X, when x being an array and we wanted to do y equals this x squared. Originally we tried this and it doesn't work, right? Incorrect dimension for raising a matrix to a power. Check the matrix is square and power is a scalar, right? To operate each element of the matrix individually, use power dot upper tick, right? For the element-wise power. Okay, so it's already giving you the error message, right? So instead, what we said is that if we want to do the x to the certain power just by itself, we'll do dot, right, to the power of 2. Or you can also do x multiplied by x, dot multiplied by x, right? X multiplied by x, that's the power of 2, okay? So you can get the results. So basically, the array of numbers in MATLAB can be interpreted as vectors and matrix if the vector or matrix algebra is to be applied. Recall that the matrices are mathematical objects that can be multiplied by the rules of matrices. So here, for example, if you're trying to have a matrix, right? Let's just do a simple matrix, 2, 3, 4. right? B is 5, 6, 7, 8. Right? So if you do A multiplied by B, which is the matrix calculation, right? So we know that the first column is going to be this row multiplied by this column, right? This row multiplied by this column, right? Second value, let's see, right? So the second value is going to be this row multiplied by the second column of B. Third value on this location is going to be this row multiplied by this column. Fourth one is this row multiplied by this column. That's the matrix calculation, right? So let's see if that's the result. So first row multiplied by first column. So 1 multiplied by 5, 2 multiplied by 7. 2 multiplied by 7 is 14 plus 5, that's 19. This is matrix calculation. But if you just want the calculation, the multiplication element by elements, 1 multiplied by 5 being the top left, 2 multiplied by 6 being the top right, right? 3 multiplied by 7 being the bottom left, 4 multiplied by 8 being the bottom right, then you will do A dot multiply B, which is here. Okay, so pay attention to the notice. This is very important when we're trying to do calculations, operations in MATLAB. Most of the time, I would say in engineering, we're going to use this dot multiply, okay? Although this matrix multiply can come quite in handy when you're trying to solve complicated problems, okay? But most of the time, we're going to use dot multiply. Or, for example, dot divide. Right? If you want to do divide element by element, then you will also do A dot divide B, right? So if you want to do A to the power of 2, right, you will do this. Okay, so basically that's A dot multiply by A. So basically to do the matrix multiplication, you need to use standard operators without preceding dot. They're not for array multiplication, division, or exponentiation. To deal with array on an element by element level, right? So let me just highlight this. So if you want to do calculation on an element by element level, we need to use the following array dot operators as I showed over here. Okay. So because scalars are equivalent to a 1-by-1 array, you can either use the standard or the dot operators when you do multiplication, division, and exponentiation scalars. So it is all okay for you to always use dot operators unless you intend to perform vector or matrix multiplication or division, right? So for example, if you want to do, let's say A, we change it to a scalar, A equal 1, B equal 2. If you want to do A multiplied by B, because both are scalars, that's okay. You can also do dot. It's still the same. So dot multiplication or without dot will give you the same results when the operators or when these variables are scalars, 1-by-1 matrix, 1-by-1 arrays. Okay, so some examples. So x equals this, y equals this, right? We want to calculate x multiplied by y on an element by element calculation, right? So you see the semicolon here, right? Semicolon will basically suppress the export of the data. So for example, if you type in here, it's going to give you what x looks like. But if you type it with a semicolon, it's going to hide the results, okay? But still, the MATLAB will do the calculation. It's just that it doesn't express the calculation over here, okay? Or assignment over here. So we can do the same. The y equals this, right? It's already defined. Y is here. So z, what is z? If you do the dot multiplication, that's going to be a point by point, element by element calculation. Use the wrong one. Multiply. Okay. Basically, it was taking the y value to the, let's say, 4 to the power of 8. It's a big value. So dot multiply will give you this. But if you don't use dot multiply, then that's a matrix multiplication. You're going to get very different results. So do not forget about the dot when you're doing scalar operations. Okay. So then it's a hierarchy of the operations, or basically the order of the operations. We learned that from basic mathematics, right? So there's an order, always an order when you do the mathematical calculation. For example, this one, right? So basically we will do the plus or minus calculation in the end. And also the calculations from left to the right, right? What comes first is the bracket. We'll do the bracket first. And then you will do the multiplication, basically exponent second, and then multiplication, division, and then addition and subtraction. Okay, parentheses, exponents first, followed by multiplication, division second, addition and subtraction last. This is what's recognized in MATLAB, right? So it's not only ourselves, but also in MATLAB, right? So for example, if you're trying to calculate, if MATLAB is trying to calculate this thing here, so it will start from the bracket, right? Okay. 3, second is exponent, third is the addition from the left to the right. Eventually you get 11.333. Okay. So hands-on exercise, enter these two arrays into MATLAB, right? So A equals 10, 5, 5, semicolon, 2, 9, 0, semicolon, 6, 8, 8. Okay. B, well, we can do B later on, right? So if you want to multiply element by element, let's type B out. 1, 0, 2, 0, 0, 0, 1, 1, 0. So you want to do element multiplication, you will do A multiplied by B. Let's give it to C. Okay, this is what you get. Dot multiplication. Okay, so next it's equal sign. The equal sign assigns value, right? So basically you have AX, assign the AX with the value of 5, BX with the value of 1, 2, CX, BY is the value of 3, 4, 3, 4. B equals BX plus BY. It's going to do the array, addition, right? Summation. So here, if you do summation, well, it's just going to be element by element, right? 1 plus 3, 2 plus 4. It's just multiplication and division are different in terms of the matrix calculation. So the equal sign commands that the number computed on the right of it is put to the variable on the left. Thus, it's assignment operation. Okay, defining or assigning arrays, right? So an array can be defined by typing in a list of numbers enclosed in the square brackets. We mentioned that square brackets is very important. So if you do, let's say, normal parentheses, it's not going to give you anything, right? Or if you use the bigger bracket, right, it's going to create a cell array. We're not going to deal with that right now. But cells are basically another structure. People actually use that to store arrays or matrices. Okay, so commas or space separate numbers. If you use commas or space, right? So you're creating one row with different columns. Semicolons indicate a new row. We already talked about that earlier, right? So, I mean, you already have A here, right? So let's just type in A equals, let's do a simple way with 3. Okay, B equals 2, 5, 2, 1, 1, 2, 0, minus 2, 6. Okay, so you see that A is a 1 row, 3 column. B is 3 row, 3 columns. What about we create a new matrix that is composed of A and B? So basically concatenate or stitch B to the end of A. All right. So now if we define a new matrix using A semicolon B, right, we're defining a new row, right? Semicolon is a new row, and then you stitch B over here, then you get a 4x3 matrix, right? The first row is being A. Okay, so this is the new matrix. And then you can also stitch, let's say, double the C, stitch it to the right. So let's define D being C, C, right? So we said that space or comma is a new column, right? So if you do that, so you're creating a matrix that's side by side, right? So it's a 4x6 matrix. Different ways of defining the arrays. So in MATLAB, there are functions to create arrays or matrix all composed of 0. So for example, if you type in zeros, 3, 5, right? So now here, notice that it's involving a function. So now we're using the parenthesis sign over here. 3, 5, it means it creates a matrix of 3 rows and 5 columns, right? So you can also do 1, 5, right? It's a single array. So let's do 5, 5. You can also do ones, right? So ones all made of 1. So you may wonder, why do we need this in the future? So actually, you can define zeros or ones in the future when you're trying to do some logic calculation. So for example, if you want to replace all of the numbers in a matrix by 0, or you want to define a new matrix, right? Define a matrix in the beginning and then start to fill in numbers. You don't want to fill in numbers of existing. You don't want to fill in existing numbers. You want to predefine. For example, we're trying to find out our test scores or homework scores, right? Each column represents a homework 1, homework 2, 3, 4, 5. Each column stands for each student, right? So before we convert all of the data into the matrix, we want to define the matrix first. Otherwise, MATLAB is going to give you the error that you don't have this row, or you don't have this column. So at the same time, if you didn't submit any homework, right, we want to make that value to be 0. Okay, so that in that case, you want to create the all 0 matrix. So then you will start to put in the value when there is a homework submission. Okay, so basically, yeah, so this is how you define the ones or zeros matrix. But if you just want to have a 5x5 matrix for composing all ones, you can only you can just do 1, right? Do 1 number. 5 is sufficient. It's going to be a square matrix. So then the next is retrieving values in the array, right? But array indexing, we talked about this earlier. 2, 1 means the row number 2, column number 1. That's 4. 3, 2, row number 3, column number 2. That's 8. Sort of like a recall session, right? You can change the value. You can also change the value in the array or matrix. So now let's say that you have this matrix if E equals 1, 5, but you don't want this value at the 4th row, 2nd column being 1. You want it to be 100. So first, if you want to retrieve this value, right, you don't need to type in any equal sign, then it's going to give you 1. But if you want to assign it to a different value, you'll do this, right? You can even assign it to be infinity. We said earlier, not a number, right? We can assign it to be 2. So on and so forth, right? This will be helpful. Like again, when we talk about the homework score assignment, you can do this to assign the value to your existing matrix. And you can also extend an array by defining a new element. For example, if you already have E equals 1, 2, 3, right? So if you want to extend the array, you can do E 100, right? Being 1. I think that's too big. So let's just do E5, E6. So now you see the E is extended to 6 elements, right? 6 columns. And then the ones in between, since we didn't define it, it's actually defined as 0. Okay. This can be quite, I would say, risky when you do the data management, because it's actually assigning a value to the array, right? So basically, it's assigning zeros to the value, and sometimes you may not want 0 in this array. colon operator. So the colon notation can be used to define evenly spaced vectors in the form, right? The first to the last, right? So if you don't define, so as we said earlier, we had this definition of 1 or 0 to 1, right? With a space of 0.1. So you can make it 10. So if you want the interval to be just 1, then you don't need, for simplification, you don't need to add column 1 here, right? So if you just do 0 to 10, it's going to give you 0 to 10. It's the same as being specifying the interval. Personally, I like to specify the interval no matter what, right? It's again a habit, right? But if you don't want 1 to be the interval, you can assign 2. So default spacing is 1. So if you want to use a different increment, you can assign 2 here. Okay, so now if you use 0 to 10, then you see 0 separated by 2. Now you may have the question, well, this is 0 to 10. What if we assign it to 11? How is it going to specify the interval? Is it going to return you an error message? No. So it's separated by 2. So basically, it in terms of this, the assigning of this of the array here, the first element and the interval is more important than the second, and than the ending element, the ending value, because it's not ending at 11. It's just using the first value separated by the interval until it reaches, right? It won't exceed the final value or the last value, right? It's just the value before the last value. Okay. So basically now if you define 0 to 10 and 0 to 11, they're the same. Okay. So extracting data with the colon operator. So if you want to extract certain value from the matrix, right? Let's see, we have D here being a matrix, right? So if you want to extract certain row here, right? So you want to extract the second row. So what you do is you will do 2. So if you specify certain value, right, 2, 3, it's going to give you 3. If you want the entire row, then you put a column, right? You can also do the same by extracting the second column, 0, 1, 5. So basically, the column will help you extract the entire row, or entire column. Again, the first number is the row. The second number is the column, right? If you use the column operator, it means everything, right? Everything in terms of the row and then the second column. Okay. So it's the same thing here. Or you can also extract not the entire row, but certain elements, right? So for example, you only want to extract the first 2 numbers of the second row. So what you do is 1 to 2, right? The first 2, and then the second row. Right? You want to do the second row, and then 1 to 2. Okay? So that's 2, 1. So if you want to do the second row, the second and third value, we will do this. Then, for example, now if we have multiple D, right? D equals, let's make it bigger. And then also make it, for example, D equals D, 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 D. So now you have a D that's made of 12 rows and 12 columns. So what if you want to get the value of the 7th row from the 6th element to the end? Right? You don't know what is end. Okay? For example, you don't know what is end. So what you do, you will specify the 7th row, and then from the 6th value to the end. You can type in end. End here has a meaning. Okay. So now if you see the values here, 7th row starting from the 6th column to the end, right? So 2 all the way to 2. Okay, so the end here bears a meaning. So if you want to get the entire row, you could alternatively just do 1 to the end. right? Or you could just do this, the same. Okay. Manipulating arrays. So for example, we were using, let's say, A equals 1, 1, 10, right? Being the column, but you may say, hey, I don't want it to be a 1 row, 10 column array. I want it to be a 10 row, 1 column. What do we do? Do the transpose. It's very easy to do transpose. So we just need to make A prime. Okay, so A prime will convert A to the column. Or if you directly want to change A, the A value itself to the column format, right? The column format, you could also do A equals A prime. And so it's going to assign the A prime, which is the vertical array, to the A value. And so there won't be a conflict over there. Okay, so manipulating the matrices. So the matrix, for example, D, we had this one. If you want D transpose, right? So you can do D, D prime. But sometimes you may want D here. Sometimes because transpose, what it means is that you convert this element to here, right? It's sort of the you're folding it or moving it in a changing the elements, reflecting the elements along this diagonal line. But sometimes you may just want to flip it, right? The last row to the first, second row to the last to the second, right? Third row, fourth row, fifth row, and the same thing. You may just want to flip it, right? So then you have the function of flip left, right, or flip up, down. Okay, so flip left to right. So it's going to, as the name indicates, you're going to flip the matrix from left to the right, right? And then flip up, down is going to flip the matrix from up to down. Okay, so these are basically practices that you can do basically do to manipulate your matrices, right? So you can extract the value from matrix, you can manipulate your matrix, and so on. So, for example, here there's an exercise: create the following matrix using the column notation, right? Column notation means that column is not semicolon, right? Column notation means that you want to create an array with certain intervals, right? So 1, 2, 3, 4, 5, you can just do 1, column 5. 10 to 18, you can do 10, column 2, column 18. 6, 5, 4, 3, 1, you can do 6, column minus 1, column 2, right? And to create this matrix, you need semicolon to separate each row here, right? So eventually you're going to do this, right? Semicolon to separate different row, and colon sign here to create the rows with fixed intervals, right? Create the following matrix using the column notation again, right? So 1.2, 2.3, these are separated by 1.1, right? These are separated by 1.9. These are separated by -3, right? So if you want to create that, so you have x equals 1.2 multiplied by column 1.1, column 5.6, semicolon 1.9, 0.9, 1.5, semicolon 0, -3, -12. So this is the matrix. So transpose this matrix and assign it to the variable y. So y equals x prime. Right. So I should have used the uppercase x here. So then extract the second row from the y and assign it to the variable z, right? The second row of, oh no, let's use it as y. It's the problem states. Extract the second row and assign it to the variable z. So you can do z equals y. Again, row comes first, right? So it should be second row, and then column, the entire row. So you have the z value being assigned over here. Okay, So now here is basically a matrix calculation with scalars. And I think due to the time limit, let's just finish here and we'll carry on from this example in our next class. Okay, so we're going to talk about how we can use the matrix calculation to solve a little bit more complicated problems.